Hi there, my name is Lars Sørensen and you're watching more content that we've created for you here over at CVC 2019 in Las Vegas. And at the Computer Vision Conference, we're talking about all these different pieces of research that are touching computer vision, but can be so wide and so different. And that's why it's interesting to present some more visitors to our conference, some attendees. Dr. Sue Taylor, Professor Sue Taylor, and Dr. Myra Lydon from the University of Belfast, right? Mm-hmm. To start off, how are your experience our conference so far?
The conference is great. It's good to see that we were doing something right in our application of computer vision, and we have learned some stuff. And everybody else is all the new algorithms and processes that we've been going through over the last 3 years. Now we can see where they've been applied in other areas and how far they've advanced and what their real capabilities are. So it's good.
A lot of things come together then, right? Sue, how is your experience so far?
You know, as Myra said, it's really, really interesting to see. I mean, we work with algorithms as engineers, but the algorithms we work with tend to be slightly different to computer science. What I think I've been really touched by is the vast area where these algorithms can be applied, from neuroscience, surgery, traffic modelling, crash. It's just such a broad area.
Yeah.
So just to see the type of feature tracking that we've been using on bridge infrastructure, how it does align with many, many diverse areas, and how computer vision and computer science can underline many areas, to help humanity.
Ideally, yes, we get to all those solutions for problems that we're having. But do you consider yourselves then the odd one out in this conference?
Well, look at this. Yeah, I'd say it is majority computer science, and sometimes we don't speak exactly the same language. We look at things like engineers. I think we always look at the practical application, where there's a lot of theoretical work being presented, but it's the practical application as engineers. Although we have just met an architect as well that's using computer vision as well.
We have. I think we'll have pretty much all different people connecting here from all different backgrounds. So I'm not a native English speaker, so I'll have to be looking for words maybe a few times in this interview. Let's dive into the research that you did and the problems that you address. You already mentioned that you're approaching it maybe more from a practical angle, and one of the examples that you gave was like monitoring the bridge. And is it then like the bridges itself or the movement over the bridge? What kind of solutions?
So our research area, it's the Intelligent Infrastructure Group, and when we say infrastructure as civil engineers, we mean civil infrastructure, not infrastructure that a computer scientist might mean. So our research in computer vision is monitoring the real response of bridges, for example, under real traffic conditions. So real measured vehicles in real time with the response of the bridge, to see how safe that infrastructure is, and to see the impact of, there's such things as connected autonomous vehicles. Near zero energy vehicles are heavier, so there's an impact for future ready civil infrastructure.
Yeah.
So that's kind of the area. At the moment, I read a stat in the USA alone, $2 trillion is needed to address deficient civil infrastructure. So that's just the USA. So if we can have a targeted response in saying, actually, this piece of civil infrastructure is actually safe due to this monitoring technique, then you are you're connecting, you're having a more connected civil infrastructure.
Yeah.
Through using vision methods.
I guess it's addressing several problems then, right? It's addressing maybe the practical side on the infrastructure itself and maintenance-wise and stuff like that, or the way it's being used or overcapacitated, but also on the other side, it's how we use it. Like if you're talking now for a train bridge or
train road,
that's it. And smart infrastructure is something that we're heading to. Yeah.
So all the from the monitoring we've done, quite a lot of our bridges do have illegal overloads. Most of them go through in the very early hours of the morning. So that's done through the monitoring work as well. So you can see, you can also work in damage detection and work out the real. So like a doctor would use multiple tools for diagnosing a human being, we're using these structural health monitoring techniques to diagnose the health of our civil infrastructure.
So I must say that also for a bit I would be shocked that of the thought that, okay, but how are we doing this now? If we're not doing it smart, there must be a lot of bridges or a lot of infrastructure that we're using every day that's not being monitored like in a smart way with multi-sensors and stuff like that. Do I have to worry?
No, because civil engineers were smart and everything was always over-designed. Like if you imagine most of the bridges that we use now every day were probably built 80 to 100 years ago when traffic loads were completely different and the demand on them was completely different, even in terms of extreme weather change. But because at that point of design there was a high factor of safety put in, then it turns that they are actually still fit for purpose. But the problem is now when they're being assessed, they're sometimes assessed in the same way for safety as when they were initially designed. So it could mean that, you know, in reality, they might not on paper meet the requirements, but if you were to test them, then you could see that that bridge still is fit for purpose because you can measure its real response under loading. So it's less of the case that the bridge isn't as safe as it's assumed. It's more prolonging the life and resilience of our bridge network and saying, you know, a lot of it is still fit for purpose, and if we do more efficient repairs and more targeted repairs, we can get a longer life out of it rather than wasting money on replacements and unnecessary repairs.
I can imagine that this is the part where you get like the governments or the other organizations that are responsible for those bridges get interested in when we're talking like cost reduction on maybe on maintenance, but also I can imagine on fabricating, because if we were able to
because we could do more efficient designs. So because we now monitor our structures, there's actually probably less of a factor of safety because we understand their behavior more truly, and we know what's going to happen in extreme traffic conditions. So it means both a more efficient maintenance program and more efficient builds. There's less materials wasted. And I mean, as the transportation, it's going to completely change. Like, it's rapidly changing all the time.
You can't even imagine, I guess, for
what it's going to be
80 years in advance.
Exactly. So maybe we won't need bridges that are 10 times stronger than they need to be. Maybe it'll be a totally different mode of transport that we'll need then. So it's just trying to get the right balance between safety and future-proofing.
Yeah. So and then maybe a little bit, because obviously I understand the research is very broad, and thank you so much. But then to understand in just a few minutes, could you tell a little bit about the how? How do you do that? Because I guess people they will understand and align on why this is important. So it is very interesting in how your approach on how to use computer vision to get all that data out. Could you tell a bit about that?
Do you want to take this one?
So there's multiple things you can measure on a bridge. So if we take one example of a truck crossing a bridge, you have a deflection response. So we can use for example, a Moses algorithm backtrack to say this vehicle has caused this influence on the bridge. But we can also track through computer vision the actual vehicle that's going over the bridge. So you can classify that through computer vision, and if you time synchronize that to the computer vision sensors monitoring the underside of the bridge, you can marry the two sets of data to say this is the health of the bridge, this is what the response is, through the algorithms and post-processing.
Which will create a lot of data, a big data flow, and so it's all about making those you say marrying the two data. It has to be a smart marriage, right?
So it has to be. I mean, one of the major challenges at the start of this research was the synchronization of the multiple sensors. But we have some very clever computer scientists working with us in our research that have managed to solve the synchronization problem or challenge. So, I mean, I guess what we see in the future is an always open road.
There you go. No downtime, like we would say in the computer science bit. Well, I think it's a great example of where the physical world, like in the engineering world, where your background lies, and computer vision touches each other and amplifies each other. Really, it's awesome. So maybe one or two last takeouts out of the research. Well, people really should dive into your research as soon as it's published, because this is a very interesting take.
Okay, well, just so you know, civil engineers save more lives than doctors because we provide clean water, safe road networks, and which fuels the economy and lets our countries and particularly rural areas thrive. So we're often forgotten about. But now that we're moving into computer vision and smarter technologies, civil infrastructure or civil engineering is going through a digital transformation, and I think we're going to be pushed right up there now with the other tech companies, and we're going to show the world what we can do.
Awesome. This is like, we'll make this video a digital shout out and love to civil engineers, and go on that wave of the digital transformation, just like you're doing, because in the end, that's what we try to do at the conference as well, because bringing all those things together, you'll get the bright ideas, the smart connections, and the interaction happening. I want to thank you so much for being with us, and I understand it's such a short time. Professor Sue Taylor and Dr. Myra Lydon from the University of Belfast. If you like this, don't keep it to yourself. Share it with your friends. Share it to an engineer, and make sure that we connect to them. And consider subscribing to our channel. We'll get all the videos out to you that we've created here. And if you don't want to miss out on everything that's going on, join us for one of our conferences. We'll have our website available in the subscription of the video. Thank you for watching this one. See you in the next.